Thank you, Gareth, and thank you very much for the invitation to be here today. I'd also like to acknowledge our former colleague who has moved on to new challenges, John Gordon, who did a lot of the work on this project as well. So I'm reporting on a lot of the work that he did, as well as other members of our team. Can you all see that?
Yeah, I can see you now, Charlotte.
Great, thank you. So a little bit about the Coal Authority. We're a non-departmental government body, and there'll be a few presentations from colleagues within the Coal Authority over the next few days. Our sponsoring department is a Department for Energy Security and Net Zero, and we have a couple of statutory functions which are primarily for protection of both people and the environment. We also do a few other things as well, and that includes the work of our team, which is the Heat and Byproduct Innovation Team. So we undertake advisory services for mine water heat schemes and the ones that require borehole drilling specifically. And we've also started mine heat R&D, which my colleague Fiona Todd is working with me on that, and she'll be talking tomorrow. The figures I've got up here are from our annual report, so if anybody wants to find out a bit more about what we do and what we intend to do in coming years, please do look for Coal Authority Annual Report online, and it's all available there for you. So this presentation will focus on the Gateshead project, which we've been supporting Gateshead local authority on this project, and we've just recently completed this work as the scheme is now operational. And it started when Gateshead had an existing 5-kilometre heat network with 4 megawatts of gas engines and private wire electricity. They came to us saying, could they double the output and the size of the heat network without necessarily doubling the carbon emissions from it? And could the mines beneath the town be the heat source for this extension to the heat network? So that's where we became involved in the project. We've also produced an IEA-GA case study, which will be going online as well. So if you go to their webpage and look under the case studies session, there'll be some more information in there. The project was very much led by the council, received government funding, which I've provided information there on the slide about that. And it's important to say that not all of that cost was down to borehole drilling. It is an integrated energy system, so they've got solar farms and other kind of low carbon and other energy systems integrated as part of the scheme. So the Coal Authority were commissioned to do the feasibility work for them, and Gateshead gave us 5 areas where they potentially had land that they could host the energy centre and the boreholes. And so we looked at those 5 areas, and we also looked at the mine plans and which collieries had worked in the area in order to identify the best seams that we would use for the scheme. And we ended up selecting the High Main seam, which is at about 50 metres beneath the site, and the Hutton seam, which is about 150 metres beneath the site. High Main for re-injection, Hutton for abstraction. And we chose these because these were the most pervasive across the sites. From the plans, it didn't look that like the High Main seam was everywhere, but there was a lot of unrecorded workings, so we were fairly confident that the very early workings on the High Main seam would be present across the majority of the area, and that's turned out to be the case. And the topside considerations that the council had meant that we ended up focusing on that kind of top red polygon we've got up there on the right and the orange area beneath it. And these abandonment plans, the first thing you notice about them is kind of their age. And so that led to complexities for georeferencing, and there'll be a little bit more on that later on. But from the start of the feasibility work, looking at the plans, we met the first criteria of getting a successful scheme, which was that we had more than one seam beneath the area, i.e. we had somewhere to take the water from and somewhere to take the water to. Moving on to the hydrogeological considerations, the next criteria we would look for a scheme is, are the seams flooded, and is the depth to the mine water within 100 metres of surface, which for UK electricity pricing looks to be round about, an economic value. So 100 metres or less is what you're looking for, unless you've got access to a lot of low carbon electricity on site. So we answered yes to both of those questions. We had flooded seams, and mine water levels there were within about 20 metres of surface. We weren't exactly sure which mine water block the scheme sits in. The UK coalfields has been rationalised into a series of blocks based on their hydraulic performance and connections between them. But we confirmed by drilling that the site was in the Walker block, and we also confirmed in drilling that the high main seam was in continuity with the River Tyne, and the Hutton seam was confined. So we had slightly different kind of aquifer performance in each. Both showed tidal responses, one direct in the high main because it was in continuity, a direct linkage. In a Hutton, it was an elastic response as the river, which is still tidal at this point, tidal loadings were causing compression of strata, and we saw changes in water level at high and low tide respectively. And we ended up installing 2 abstraction boreholes because Gateshead wanted to have some flexibility on the scheme so that they didn't always have to run from one borehole. So they could, if they wanted peak loads, they would run 2, and at lower times they could run one or the other, which gives them a bit more flexibility and resilience on the system. So we installed 2 abstractions, working with Drill Corps, who did the drilling on this. We supervised, and these boreholes were fully cased down to the Hutton seam and capable of housing 8-inch pumps. We also put in 1 re-injection borehole, which was 20-inch casing down to about 39 metres, so the high main was a little bit shallower in this area. And then we undertook test pumping. Once we got the abstraction and the re-injection, we used one of the abstractions to test the kind of doublet that we'd created. And the blue line from the first set of test pumping shows that the drawdown didn't stabilise when we did step testing. And also the drawdown became unacceptable in terms of maintaining enough water above the pump. So, and we also saw a very flat response across the Hutton seam. The analogy of this being that you're pulling on a plugged syringe effectively, the experiment you do in school on compressibility of fluids, when you're trying to, and they give you a syringe with water in and the end's been sealed off, you're trying to pull the plunger on the syringe out and it won't. And that's kind of what we were seeing here. So we knew the Hutton contained water, we knew it contained voids, but it wouldn't hand it over quite as easily as we wanted to, so we couldn't quite get the yields as wanted. So a modification to the plan was required, and that involved pulling back the casing on one of the abstractions to expose the high main. And then we repeated the test pumping, and that's the orange curve you can see above. And that led to depressurization of the Hutton seam, and drawdown stabilised, was within acceptable limits, and the scheme performed, the boreholes performed much more efficiently. So what we ended up doing to preserve the 2 abstractions to keep the flexibility on resilience of the scheme, we drilled another borehole, a multi-seam borehole, which connects those 2 together and effectively acts to depressurize that system. So this gives you a diagram of the conceptual model of what we ended up with. So we've got the 2 abstractions, the re-injection, you can see the multi-seam borehole there. And the way when the scheme's operating, the water's pumped from the mine, goes through the heat exchanger and returned underground. The temperatures we're finding in the Hutton seam were between 15 and 16 degrees, around about 150 metres, and in the high main at about 40 metres were 11 degrees C. When the scheme runs, about 50% of the flow rate goes down the multi-seam borehole, and when the scheme stops, the flow reverses in the multi-seam borehole. And that's something we'll gather more information on when the scheme operates. And we did more testing at constant rates on both the abstractions together. And during those short duration tests, we haven't seen any decline in temperature. But again, that's something we'll be watching going forwards. So the heat pumps and an ammonia-based heat pump working at COP of 3, operating around 2,500 hours per year. So it's important to note that it's not running all the time. It's only running, you're not doing peak loads all the time. It's maybe only running at peak for a few hours a day, and it isn't running every day of the year. It's been permitted by the EA and licensed by the Coal Authority Heat Access Team, and I know there'll be presentations on lots of those aspects coming up over the next days. And it's now in operation, and we're really excited to see how it's performing long term. So the challenges we've had with the georeferencing of the old plans, meaning that more boreholes had to be drilled than required. And obviously we identified the need for the interconnecting borehole as well. So that was another borehole that was required too. But it's compared to some low carbon heat techs, we're using existing technology, and it was a relatively quick project to do. It's a really good example of how a local authority has led the way and incrementally increased their risk appetite by building on the success of previous energy projects they've had. And for me, the fact that the coal's been mined, traded and burned, but the water that's replaced it, we can use that over and over again. And I think I really like Florian's comment about eternity benefits and eternity burdens really much more eloquently than I've said it here, but I love that aspect of it. I've had a personal interest in this over the past 10, 20 years, and I'm delighted to have had the opportunity to be involved in this scheme, and we're very excited to see it as it goes forward. So I'm now going to hand over to my colleague Dan and just say thank you for listening. And this is some of the people that were involved in the scheme, all of whom I'm sure would be able to give you a presentation on their aspects of this project as well. Very much collaborative. So thank you. Over to you, Dan.